Okay, here's a nice stoic question. I thought it was a three-stepper, but it's a two-stepper. Let's take a look at it. What number of moles of ammonia can be produced? So we're producing ammonia. It's ammonia, and it's a gas from 8.56 grams of hydrogen gas. So I'm reacting hydrogen gas with excess nitrogen gas. Nitrogen gas. Okay, need to balance. I think I'm putting a 2 here. That'll give me 2 nitrogens. I have 2 nitrogens here, so this gets a 1. And this gives me 6 hydrogens, so I need a 3 here to balance the hydrogens. Okay, so now I need to figure out what steps I have. Let me do my solid liquid gas, and then moles in the middle. So they're giving me 8.56 grams, and this is a mass of hydrogen. So they're starting me at a solid, and and that's what's given. And what's asked is how many moles of ammonia. So I just have to stop here. So the steps I'm going to be doing is to convert this solid, the grams, into moles. That'll be step 1. And then step 2 will be to go across the river to take moles. This side would be the hydrogen side, and this side would be the ammonia side. Okay, so 2 steps. Let's do step 1. So step 1, I have to convert mass of hydrogen into moles of hydrogen. Okay, so mass, that's this one up here. That's a solid. So mass of that, and I'm converting it into moles of hydrogen. Okay, so to do that, I use this formula, mass over molar mass. The mass is 8.56 grams divided by the molar mass of hydrogen. Hydrogen is 1.01, but since there's 2 of them, that'll be 2.02 grams per mole is equal to, okay, let me get a calculator. It's going to be 4 point something. 8.56 divide 2.02. 4.2376. Excuse me. Moles, and this is of hydrogen. Okay, so this thing here, I've gone from mass, and now I'm at moles right here. So now I need to get across the river. Sorry. So I need to get across the river, and to do that, you use the mole ratio. So to do step 2, I'm taking moles of hydrogen and converting those to moles of ammonia. Okay, and I'll use these mole ratios that I have in the balanced chemical equation. Notice once it's balanced, I don't need that one. So I have 4.2376 moles of hydrogen multiplied by 3 moles of hydrogen react to produce 2 moles of ammonia. Okay, so now I multiply it by 2/3. So take that number you had in your calculator and just go times 2 and divide it by 3. So I'm getting 2.82508, etc. These cancel, so this will be moles of ammonia. So now I've crossed the river, I'm at that stage right there, and that's what they were looking for. So to round this to sig figs, I've got 3 sig figs here, so it'll be 2.83 moles of ammonia right there. Now, had they asked you what is the mass of ammonia gas, let me do that with a different color. If they'd asked me for the mass of the ammonia gas, I'd had to do one more step. I'm going to do it. So I wanted to take the moles of ammonia gas and convert it to mass of ammonia gas. Okay, so this formula is the same as the one before, but you have to manipulate it for mass. So that'll be mass is equal to moles times molar mass The moles are, we just got 2.82508 moles, times the molar mass of ammonia, 1 nitrogen and 3 hydrogens. Nitrogen's 1401, 3 hydrogens would be 303, so that'll be 17.04 grams per mole. Moles cancel, so if you multiply those two times 17.04, I get 48.139 grams of ammonia. I'd round it to sig figs, 3, so 48.1. Now, I just want to think about this. Yeah, that'd be right. I was just thinking I might be a little bit high, but in terms of here, hydrogen's very light, and if there's 3 moles of that, that's a lot of hydrogen. And so if you convert that to ammonia, which is a little bit bigger molecule, you'd get something quite a bit heavier. Yeah. All right, hopefully that helps you with that one.